Hey, what's up, everybody? It's time for Astronomy Daily Live, and I'm trying to get this going, but for some reason, my machine just decided to just go slow. Just go slow. It's not fair. So bear with me while I try to get this out. I'm having to do this left-handed, which is always a challenge for us right-handers. um, and yeah, man, this thing is just being incredibly slow. I think it's Uncle Bill's fault. It's got to be Uncle Bill's fault, right? Okay, let's put that one up. Man, for some reason, yeah, this is just being incredibly slow on my end too. I don't know what's going on. We're not on the same ISP, are we? No, it's my machine. My machine is being really slow. I mean, I right clicked to copy over this text, and it's like a minute later, it's there. So yeah, something weird's going on with my machine. Not too surprised. Not too surprised at all. So yeah, I hope everybody's doing well out there in the universe. Everything's good here. Everything's good. Um, Looks like we're getting a little pre-monsoon weather, which is okay. Don't mind that a bit. The only real problem with that is the dry lightning, which can be a problem. Yeah, see, this thing has totally frozen. That's crazy. Yeah, it just the whole thing just crashed. That's insane. That is insane. Not quite sure why that would do that, but I'm going to reload it. And actually, I'm just going to kill that. I think I can do that. So I was looking through archive.org just before we went on here and restore this tab and see if that actually works. Yeah, okay. Yeah, well, sorry about the unstable ISP, Uncle Bill. Yeah, that sucks. Hey there, Bobby, Patrick, Tom. Nice to see you. Glad you could stop by. Yeah, so I was looking at archive.org and noticed that they had a paper there about, I'm using the wrong mouse here, um, the Hubble Deep Ultraviolet Legacy Survey that yeah, well, most things I don't hear about or know about unless I stumble upon them or hear about them. But yeah, didn't hear that one. Hey there, Tim. Nice to see you. Nice to see you. You're still awake. That's awesome. That's awesome. So yeah, I was looking at the at that paper, and they reference a site where you can go grab the raw data. So I was going to start doing that, and then I realized the files are really big, at least relatively speaking. Here, 1.3 gigs. So I've got a pretty slow internet, so that would have taken a while, and I knew that I was going to have um, that. I'm already sort of stressing my bandwidth pipe here, so yeah, it was just a little bit easier to not download that. But it turns out, and I'm gonna get on this right away here, just for fun. We'll see. I really like to follow follow the nose, see where it wants to go. So here's the actual paper. Let's pull that up. So the Hubble Deep Ultraviolet Legacy Survey. We present the HDUV, and it's 130 orbit imaging program with the wide field camera 3 and the ultraviolet. I don't know what IS stands for. I don't remember. Um, onboard HST, right? And they did some deep images um, over 100 square arc minutes with two sort of ultraviolet filters, right? 275 nanometers and 336 are definitely ultraviolet. They're not super ultraviolet, right? They're just sort of the regular ultraviolet. 336 is just outside of our visibility, right? So just on the blue side of violet, I guess you can say. Um, but they reach depths to like 28th magnitude. That's pretty good. Um, so I guess, and it says that these are the deepest high resolution ultraviolet data over such a large area taken to date. So I mean, uh, that's that's great, but um, I mean, you can characterize anything to make it sound good. So that's um, let's see, among the main goals of the survey are to provide a complete sample of faint star-forming galaxies at Z of approximately 1 to 3. So Z, of course, is a measure of redshift, and a Z of 1 to 3. And redshift, if you believe, sort of the dogma at the moment, um, redshift is an indicator of distance. So the larger the redshift, the larger the distance. And so, yeah, I think a Z of between 1 and 3 puts it pretty far out there. These are supposedly pretty distant objects. You know, uh, certainly billions of light years away, right? I think I can say that with some pretty high confidence. So yeah, this paper is just um, going through how the data was constructed and what they did to reduce it. I guess the wide field camera 3 is experiencing some systematic problems just due to age, right? Just due to age. The camera itself is looking pretty bad, right? But they have apparently found a way or found ways of dealing with that. Let's dive into the paper here because they've got some pictures that I can show you that will sort of well show you what I'm talking about. So let's see, they can. So yeah, here's the here are all the filters that HST has access to, right? That covers from about 0.25 micron all the way up to what 1.6 ish or so. So of course these are the ultraviolet. 400 or zero point 0.4 microns, right, is 4,000 angstroms. 400 nanometers. So yeah, these are the two filters that they use to do this survey, right? And so yeah, and here's the field that they decided to look in. Blah blah blah. Good stuff. It's a nice paper, right? And they actually say they got it from the archive here, and there's a reference, and we're actually going to be going over there soon. So hold on to your hats. But this is just grabbing the data and processing it. So yeah, this is what they start with, and this is what they end with. Actually, after they've processed it through. And so, yeah, that's not bad. You know, it cleans up really, really nice. Looks pretty good. I don't think they have any stats plotted here or anything, but here's some images of the same field looking at different wavelengths. And yeah, that's pretty cool. It's pretty cool. Um, but I looked at this and that's great. And I thoroughly encourage you to take a look at this paper too. It's very awesome. You can learn a lot. I mean, you know, all these are like that, right? It's just hey there, Jill. Nice to see you in the chat. Um, you know, all these papers are jumping off points, both in terms of, you know, the learning curve, but it's also in terms of history, right? Because you can, um, you know, every place that you see a reference is a reference to past work. So, you know, these references are usually um, there because of what was just stated, right? So you know, if you want to find out any information about what they just said, right, then you can go to the references. But what the references are is sort of like a historical record of these concepts. And so it's sort of like reading like the Supreme Court um, uh, um, things that I mean, every almost well, yeah, I can say that every um, Supreme Court, oh, I forget what the term is, but every Supreme Court opinion uh, is like a history lesson, right? It's really, really amazing, and these are the same way. All these references, right, take you back in time, and then you know to another paper, right, and then that paper is going to have references to a previous time, so you can go back and back and back and back and back. You can, you know, find the origin of these concepts and then sort of trace them through, you know, and see how they've changed, see how they've evolved. I mean, you know, so for a historian, like a science historian, any one of these, any paper, right, is a starting point, is a jumping off point to you know the history of you know hundreds of different kinds of concepts. So and I sort of like these kinds of papers because it's um, you know it goes through in gory detail, right? How they grab the data, you know, grab the data, how they reduced it, how they fixed them, um, you know, and then sort of an analysis of the results. Uh, so I can appreciate that for sure. You know, so much work goes into these things. It's just crazy. It's just crazy. So very very awesome stuff. But what I noticed up here is that they actually have a link. It says all here. I can zoom in a little bit. All of the HD UV data products are available at this particular site. So I don't even have to go and find them, right? You can just go to this site and get them that way. And so I did. And let's see, let's go all the way back so I'm not biasing in any way. Okay, so this this is that site, right? The HD UV data release 1.0, which I don't know. Does it give a date as to when this was? The last updated 5/22/2018. So I don't know if that's when this data release occurred, or if that's just the last time this particular web page was updated. Which means anytime it's touched, right? If they change a word, then it's been updated. So, um, but so what I noticed here is that they do have the data products themselves, right? Which are these huge FITS files, that I was talking about, 1.3 gigs each. It's like, oh, okay, blah blah. But then look at that. I saw that they have interactive displays. So let's go over there. I was already over there um, a while ago, but let's take a look over here. Well, and see. So I guess these are the fields of view that they were interested in, right? It's just these four, right? There's a goods north and a goods south, and I don't remember what do they what do they call what is goods here? Let's find out. Somewhere there's going to be a reference to goods. Uh, there's one in the caption there. Survey design. Oh, they don't say what goods stands for. Who knows? It's some kind of crazy crazy thing of some sort, as most astronomy things are. Yeah, I don't see any other references to goods. So yeah, we're gonna have to figure out exactly what that is. But anyway, four fields of view. Um, let's just take a look here. So this is at 336 nanometers. Don't know really what to expect here. So HDUV goods north, it says. It's still loading, so patience, please. Take a nice big gulp of dihydrogen oxide, H2O. It's very energetic, and that's what I'm consuming this evening. Here is some good old dihydrogen oxide. Some people call it dihydrogen monoxide, and I guess that's okay. So let's see. Let's zoom out a little bit. These are some weird looking galaxies here, but wow, look at all of them. So these are galaxies that are glowing, I guess you can say, in the ultraviolet. Okay, so that's sort of one edge. So you kind of get an idea about how big these are. Well, not necessarily how big they are, but sort of the edges. There's a nice little spiral galaxy down here that I noticed before. Let's zoom in on him and see what he's got to say. Pretty amazing resolution, gotta say. Gee whiz. Yeah, that's pretty nice. You can see, you know, these are probably some kind of star forming regions in this spiral galaxy, this little tiny, faint little spiral galaxy. Let's see. Okay, I'm looking up here, right? And so what I can do is I can sort of measure the distance from here over to here. Actually, let's do it in dex, so it's in arc seconds. So let's start here. So we're at 4375, right? That's the last two or the last number there, 4375, and that's 5131. So that's a little more than 5 arc seconds across, right? 5 arc seconds across. Now, yeah, that's pretty good resolution, but that's what you can get when you're above the atmosphere of the Earth, and you don't have any of the blurring effects, right? You can get these. So, you know, this center portion here, right, 4639 to 4807 is 2 arc seconds in size. That's about as good as you can do down here on the ground, right? Is about that size, right? That's called good seeing. You know, when you have um, 1 or 2 arc second seeing, that's called good seeing. That's awesome. But look, I mean, they're getting down here where we're seeing structures, right, that are, let's see this one, right, 50.41 to 50.67. So that's zero point 0.2 arc seconds. That's 200 milli arc seconds across. And you have pixels in between there. So pretty good, but that's HST for you, right? That's HST for you. So I guess they're, let's see, we can invert these images. Let's see, let's go to visible area so it's a little bit faster, and then let's invert it. Okay, yeah. So it just, it just makes all the black things white and all the white things black. Sometimes it's easier for our eyes to see things with this kind of contrast as opposed to that. I guess it probably sort of depends on the individual, but I sort of see things better that way. But that's just me. So let's zoom out again here and see if there's anything else. And this looks like a cleaned up image, but I mean, just look at them all. Look at all the galaxies, and it's kind of interesting. You know, a lot of them have the same size, right, or sort of the same size. But these are all galaxies. Galaxies, you know, much further away, which implies at least that they're, you know, we're seeing them as they were long ago, right? So we're not seeing these galaxies as the same age as our galaxy is now. We're seeing them as they were younger. But in terms of number of stars and number of things going on, they're comparable. But yeah, some pretty interesting looking stuff going on here for sure. Yeah. Let's see. We can scan around this way. That's kind of interesting there. That's a weird looking blobby thing of some sort. I was trying to see if we could. This wasn't. I was trying to go lighter and lighter and darker and dark. Oh, okay. Well, I obviously had to wait. Let's see if we can go darker and darker here and see what that does. Obviously, I've never used this before, so I don't know. Yeah, I'm not seeing anything. You can play with the sky. You can go darker on the sky. I don't know if that does anything. Oh, it does. Oh, okay. Well, that's the wrong way. Let's see if I go the other way here. Oh, this is saturation. Okay. Yeah, sorry. I'm doing the wrong one. Let's reset it and let's go darker on the sky. I was looking at the wrong thing here. Okay, yeah, it's changing it a little bit. Yeah, pretty cool. It's nice to have an interactive thing for these kinds of things. You can't really do any kind of science, I don't think, with that. Um, there's a couple of numbers here that pop up. I'm not exactly sure what these two numbers are, and I don't know what that bottom number is either. 0.036. I don't know. Is it 0.001? So maybe it's some kind of intensity. 003. Yeah, I'm not quite sure. Not quite sure what that is. Let's see. Let's zoom out a little bit. So anyway, pretty cool to have access to this kind of data, of course. Yeah, there's some pretty wild looking shit over here. Yeah, wow. Pretty awesome. So, just as a reminder, this is ultraviolet light. So typically what that means is that you're seeing higher energy types of events, right? But yeah, there's some weird shit going on there for sure. Yeah, wow. And again, these are, I mean, if you if you agree with the current understanding of all these things, we're seeing these objects as they were billions of years ago, right? I mean, long time ago. So they've had a chance to evolve. So who knows what they look like now, right? We have no way of knowing that, but this is what they look like then, and yeah, pretty interesting. Pretty cool. Well, I don't mean to be zooming in. I mean to be zooming out. But it's absolutely amazing, how many objects, right? How many galaxies. There aren't a lot of stars here. They do that on purpose, right? They try to choose a portion of the sky that doesn't have a lot of stars because, a lot of stars is just a hassle, right? Because I mean, they're really bright and they tend to saturate, the CCD if you're doing these long exposures and all of that. So it's nice not to have a lot of stars in these fields of view, and there really aren't, but there are some pretty far out looking. Now, what I would like to do, right, is I would like to take these different wavelengths, right? We've got the two different wavelengths here, and combine them. Make make this red and this blue, or something, um, and see if we can gather any additional information by seeing colors, right? But for now, let's should we invert these back just to sort of see what they look like that way? And I'm gonna reset the sky so it's back to sort of default, right? So now let's zoom back out. Pretty amazing. What did they say? Did they I mean, I know they said 138 orbits, but did they actually tell us like how long the exposure was? Let's see. Let's see if we can find it really quick. Um, so good south pointings. Uh, yeah, it's not saying how many seconds, right? They just talking about orbits here. So let's keep looking. Bum, 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 bum. Not seeing much of anything. Sky darks, alignments. So HDUV summary, area, exposure time. Okay, so So they're talking about 10.1 orbits, assuming 2,400 seconds per orbit. All right, so I'm going to go grab my handy dandy calculator here. And what, that's 2,400 seconds times 10.1. So that's 24,240 seconds, which is what, 36 divided by 3,600 seconds per hour. So that's 6.7 hours, 6.7 hour long exposure. That one, and then yeah, this one looks like about the same, right? About the same. Okay, so that's south and that's north. So yeah, the north had maybe had a little bit more, but not much. They they kept them about the same. Okay, so that's about a 6 or 7 hour long exposure. Okay, not bad. Not bad at all. Can we okay, I don't know what exactly that's doing, so let's zoom out a little bit more. We can scan around here. Just look at all that fuzziness, though. Whoop, I think I zoomed in a little too far. Pretty incredible. Lots of galaxies. More galaxies than what we can possibly even imagine. Look at that. Gee whiz. That's a pretty funky looking thing. Looks overexposed, too. Let's zoom in on him really quick. And wow. Is that cool or what? Look at all those. Huh. What is going on here? Look at that. It's, I mean, I guess what we're seeing is, you know, star forming regions, right? That's why they're so bright. But yeah, what kind of galaxy is that? I don't know. That's pretty far out. I like it. There's another one just like that one. Now that looks like a star, right? It's got some diffraction spikes on it. But look at these blobby things. Look at these weird blobby things. Pretty incredible. I don't know what that blue square is. That's kind of annoying. Yeah, I've got the blue square of death here. Pretty far out though. Some pretty interesting looking galaxies. Ooh, here's a barred. Here's a barred galaxy. Wow. That's amazing. Check that out. Gee whiz. That's pretty incredible. Pretty incredible. Yeah, this is definitely a galaxy far, far away. Yeah, very awesome. So pretty cool. Pretty cool to have access to this kind of data. Look at this one. Wow. I hope you guys enjoy this as much as I do. This just, I mean, I don't know. Just nerding out, looking at, you know, millions or billions of stars. I don't know. I think it's pretty awesome. And so many of them. Let's invert this. See if it. Yeah. Wow. Pretty cool. Wow. Here's another nice looking one down here. So that's just the north, right? That's just the north at one wavelength. So we can look at. I haven't looked at the south one yet. Let's look at the south one. Yeah, Patrick. It hurts the head. It hurts even my head. And I've been in this game for 30 years. It still just blows my mind. Mind blowing. And there's some good data in here too, right? I mean, this isn't just like a peep show or anything where it's just like, oh, let's look at the pretty galaxies. It's like there's useful data here, right? There is um, lots of useful information here. Just got to tug it out, right? And this paper, to a certain extent, does that. At least it sort of, helps you along the way a little bit. But wow, that's just incredible. Let's darken the sky a little bit. I sort of like that, darkening it just a wee bit. Let's do just the visible area too. I think it's trying. I don't know. Seems to take it a couple of seconds to go through its operation here. Yeah, it looks like it's getting darker. Let's see how dark we can go. Ooh. Okay. That's pretty awesome. Can we invert this? Wow. Looks like there's still some. I mean, I don't know if I would necessarily call that a that looks like an artifact of some sort, not necessarily an object. But yeah, what do I know? Not much. So that's pretty cool. Galaxies everywhere, right? I mean, the the deeper we look, the more we find, right? These all these galaxies, at least all these spirals, are really blobby, right? They have these bright blobby regions in them, which I mean, as I said, that sort of indicates um, to me, if you sort of agree with the current ideas about how things evolved and all of that, then those are like star forming regions and really sort of bizarre shapes. Yeah, pretty interesting. So here's another one that's just weird looking. You know, don't get me wrong. I like weird looking, but yeah, that's just pretty strange. Pretty strange looking stuff. I like it. I like it. Cool. Well, I'm sort of glad I found that. As I said, read through it. It's a good read, and so much work is put into the writing of these papers. It's just amazing. Wow, look at that! Just bizarre structure. What is going on? Wow. So yeah, again, just to put this into context, these as the story goes, these are galaxies as they were, um, you know, probably a billion-ish or so years ago. We can actually, let's look that up really quick and see if we can redshift uh, redshift Z redshift conversion chart. Oh, that's not quite what we want. Oh, yeah, well, let's do it. So a Z of 1 is oh, that's not helping much. British. Oh, these are kind of weird units here. Astronomical, let's show those. Whoop. These are just conversions. I'm not exactly sure what this is showing. Let's see if I change this. 0.1. Heard me. These numbers change. I guess it did. Did it? How about Z of 0? Can we do that? Ah, yeah. How about 0.0? Well, let's 0.001. I'm trying to make sure that this is working because I don't want to mess with you guys more than what I have to. So that's saying 13 million light years. Okay. All right. Well, I can sort of believe that, right? So they're saying that these galaxies are between a redshift of 1 and 3. So let's do a redshift of 2 and see how many light years that is. So it looks like I'm way off. 27 billion light years? I'm finding a problem with that. But gee, what do I know? Huh. I'm not sure about that. Don't trust that. Don't trust that number because that is a little questionable to me. That seems awfully big. Hey there, Andrea in Wonderland. Nice to see you on the chat. Yeah, thanks for stopping by. We're looking at the Hubble. What was it called? The um, Hubble Deep Ultraviolet Legacy Survey. So yeah, we're just playing around a little bit with looking at some pictures tonight because I love pictures, especially these kind where there's so many strange and interesting things. You know, needless um, to say, these galaxies are far, far away, and so we're seeing them as they were when they were much younger than what they are now, and they're just turning up some really bizarre shapes, right? Which I guess is to be expected, right? I mean, if you sort of agree with, you know, how these things evolved, right? They started a little weird and then they got more organized over time. But yeah, some of these are just crazy looking, right? Let's look at this one. It's right next to a bright star. Now that's definitely a star, so I can see the diffraction spikes. But yeah, some pretty weird looking stuff going on there, right? And this is ultraviolet light, so this is pretty energetic activity. Pretty energetic, but pretty interesting, and so many galaxies. Just insane, right? Different sizes, different shapes. Look at this one. It's a ring. Ooh. Ooh. Oh, that's nice. Isn't this universe a great place, to have, to know that we're in the same universe as this kind of thing? Is that cool or what? You know? And what is going on there? There's just like these, I mean, look at that. There's just like these strings of beads on here. These are all, you know, star forming regions, I guess. You know, they're regions of high energy, right? Because they're emitting pretty brightly in the ultraviolet. So, yeah, what's going on there? Who knows? But wow, isn't that pretty? Look at this one. That's just crazy, man. I'll tell you. Wow, look, that is just, that is really bizarre. That is really, I like it. Man, what is going on there? I mean, you know, you can sort of tell, right, that there's some kind of spiraling going on, but look at all these bright blobs. I mean, sort of evenly spaced. I don't know. It's pretty cool. Pretty cool for sure. Let's um let's move away from galaxies a little bit, and I wanted to just give another plug to cloudynights.com. If you haven't uh, gotten on their site yet, check them out. Um, this is a very, very active group, mainly amateur astronomers, I guess you can call them. But these people are pretty serious, right? And very active, and I like it. One of the things that they publish every month, this um, Dave Mitski, he he publishes a really awesome calendar of events, things that are going on in the sky uh, for the current month. And we've gone through a few of these already. Yesterday was the superior conjunction of Mercury, so that's a, yeah, not an incredibly rare event, but it's pretty cool to actually see it happening live, right? That was very cool. Um, but yeah, you know, we're going through sort of the solstice time now, so I think solstice. Um, let's see. Do they talk about solstice? Remember if they actually mention solstice or not, which is kind of strange that he's not mentioning the solstice. But yeah, I'm pretty sure that the solstice this year takes place on June 21st at 10:08 UTC. So you have to figure out what time that is for where you are on the planet, right? So for me, I'm I'm in southeastern Arizona in the United States, and so 10:08 UTC for me is 7 hours behind that, so 3:08 a.m. So you know, not going to be able to look at the sun because it's going to be in the morning still. But let's see, you folks over in Europe, right? The sun is definitely up by 10 a.m. Right? Um, and 11 o'clock and noon and 1 and all of that, right? Going across Europe and Africa, you will definitely see the sun at solstice. So if you remember to, go take a look. Don't look too long. Okay, don't look too long, but you can glance at the sun and not have any kind of problem there, right? So at the appointed time, right? Uh, um, uh, I would say go outside, glance at the sun, and wave, right? And say, you're as high um, a declination as you're going to get for this entire year. This is as high as you get. and you can read that any way you want. Oh, cool. Yeah. Anna isn't even um, she's getting into twilight, and that's it, huh? Yeah. She's pretty far north, huh? Yeah, you got to be pretty high up north uh, to not get real darkness, right? I think real darkness, right? Astronomical. Well, the end of astronomical twilight is when the sun is 18 degrees below the horizon or more, right? So in order um, to experience astronomical, well, in order to not experience any kind of twilight at all, right, you've got to be 90 degrees minus 18 degrees. So you have to be at a latitude uh, greater than 72 degrees north in order to not have any, or to only have twilight time. Uh, so yeah, that's pretty intense. That's pretty intense. Pretty cool too. I think I did that math right. So let's see what else is going on. So that's happening on the 21st. Um, oh, he actually does say it right here. Summer solstice in the northern hemisphere occurs at 10:08. Um, so let's see. On the 22nd, the moon is sort of close to Spica, not incredibly close. Um, Mercury, the moon. So now I'm looking on June 24th. The latest evening twilight of the year at latitude 40 degrees north occurs today. Um, Mercury, the moon again. So yeah, Mars is stationary in right ascension, right? So what's starting to happen there, right, is that the Earth is starting to catch up to the motion of Mars. So their relative motion, the motion uh, between Earth and Mars can slow down and sometimes stop. And sometimes it stops in one axis, sometimes it stops in the other axis, and sometimes it stops in both. And in this case, apparently, it stops in the right ascension axis, sort of east-west, right? Um, and then it starts to move westward, at least according, well, or relative to us, uh, starting at 14 hours UTC. And at the end of the month, the last day of June, the moon is going to be at apogee, which is the furthest away it's going to be in this orbit, at a distance of 406,000 kilometers. It's also what they're calling at the ascending node. The ascending node is when the moon reaches a declination of 0 degrees, and in this case, uh, it'll apparently be moving towards the north. So then, if that isn't enough, right? Dave Mitski provides all this information in terms of dates and times and all that kind of stuff. He also has all this other pretty interesting information, a lot of um, historical events, like the Tunguska event happened on June 30th, 1908. Um, this guy discovered a supernova in 1989. Okay, yay. Um, Meteor showers, iridium flares. So yeah, it's all really cool stuff. A lot of information. I mean, I mean, I don't know Dave Mitski at all, but I gotta thank him because it's just some really useful, interesting information, right? And I mean, I don't know about you, but I like to have more information than what I really want. Um, I don't like to be starved for um, data. And Dave, man, he does not starve at all. He lays it out full plate, right? Full plate. You can grab what you want, which is very, very cool. Uh, so Vesta reaches opposition on June 19th. That's the closest that it's going to get to us this time around. And it's going to be pretty bright, magnitude 5.3. Yeah, I'll be able to see that in my scope. Maybe I should, June 19th, maybe I should look at that. I've got a few days. Could be interesting. Could be interesting. Definitely be able to see some motion over the course of an hour or so. Um, so that might be an interesting opportunity to do some kind of live stream. I don't know. Looking at Vesta, yeah, maybe, maybe. Um, yeah, let's think about that. That might be kind of interesting. I'm not going to be able to resolve it, right? I mean, it's pretty small. It's 7/10 of an arc second in size. So I'm not going to be able to resolve that, but I'll definitely be able to see it and see how it moves. Yeah, could be kind of cool. I'm going to try to remember to do that. I'm going to try to remember to get set up on the 19th for that so we can watch Vesta move. Maybe do a thing where I don't know where the moon is going to be, but maybe look at the moon, look at Jupiter, look at Vesta, spend an hour or so, chit chatting a little bit, look at Vesta again and see if it's moved. Pretty cool. I think we can do that. All right. Well, I think that I am going to call it a day, call it a live stream, get out of here maybe a little bit earlier than normal, leave it to about an hour or so, something like that. So yeah, I hope everybody enjoyed that. I it's pretty amazing the kind of work that is being done, and it's also so amazing that we have access to it. Um, so yeah, maybe I'll make some color pictures. I don't know. We'll see how it goes. Yeah, we'll see how it goes. See how it goes. I definitely want to investigate uh, those aurora on Saturn a little bit more too. I thought that was pretty cool. Pretty cool. Wasn't I guess I wasn't necessarily aware uh, uh, of that. So that we could see those kinds of things. So I think that's pretty cool. Definitely want to get some pictures of that. So make some colors of those too. So, all right, I'm going to get out of here for now. So, hope everybody has a great evening, a great day. Uh, hit the thumbs up if you so desire. Make some comments. Share this around. Trying to find our core group, those who share a similar passion for science in general, but astronomical things specifically. Um, there is so much to talk about. There's so much to learn. There's so much to know, and there's so much to share that never ever run out of topics or anything. And definitely, you guys bring some stuff up. Post some things on the Discord um, server. Uncle Bill sent you a link there to it. So if you haven't joined that yet, we can have conversations all day long, right? I try to check on those things. So yeah, and check out all the other science related streams. They're all great people, right? Then they know so much. It's just mind blowing, right? Um, so yeah, if you like those kind of things, now for me, I'm going right to Doctor Who. so so that's where I'm going. I'm going to go to Doctor Whoville and spend the rest of the evening watching Doctor Who. They're on the second Doctor now, right? The second Doctor. I'm looking forward to the third Doctor. He's probably my favorite one, John Pertwee. Uh, but I like it all. I like all the old classic Doctor Who. I don't particularly like any of the new stuff. I think it's just a little too much. So that's just me. All right, I'm going to get out of here for now. Thanks for stopping in. Peace, cheers, and all of that. I will see you again on the spin. One spin of this planet's axis uh, in a little less than 23 hours. All right. Take care, everybody. Bye.